Hello, everyone. In this video, we're going to take a look at the TVM in-class practice problems. And so if you're looking for this problem set on the learning platform, then you can go to course content, unit 1, what to do, and you'll find this set of practice problems. Okay, I'm just going to go ahead and set the table for this video. In this video, we're going to work the first 6 problems in this practice set. And we're going to work those problems both on the calculator and in Excel. Don't worry, if this is something that's new to you, we're going to start from the very beginning. If this is something that you've done in the past, this will be a nice refresher. Just as a reminder, I'm going to use the Texas Instruments BA2 Plus calculator to work these problems. If that's the calculator that you're using, then that'll be great because this will be good step-by-step instructions. If you're used to using a different type of calculator, HP has a financial calculator that's pretty popular. You're more than welcome to use that calculator. I just won't be as helpful on that as I am with this calculator. All right, that said, let's go ahead and dive right in and get started with these problems. So in number 1, it says that Alex received $30,000 from an inheritance and wants to invest it for the next 20 years. If he can earn 7.5% per year, how much will his account be worth? Okay, so before we start just working this problem, I want to talk about an approach that I think is really helpful if you're new to this content. So the first thing that I like to advise students to do when they're looking at time value of money problems is ask themselves, is there a payment? Okay, so we talked about this in the introduction to the time value of money. And we defined a payment as something that happens on a recurring basis for a set period of time. Okay? And so the question then becomes, is there something in this problem that happens on a recurring basis for a set period of time? And the answer is no, right? We have an inheritance. That's a one-time event. Alex wants to invest that inheritance. That's also a one-time event. And he wants to know what it's going to be worth at the end of 20 years given an interest rate. Okay, so the answer to the payment question here is no. If the answer to that question is no, then the next thing that I ask myself is, does interest compound more than annually? All right, well, we don't have anything to lead us to believe that interest is being compounded more than annually. And so when we talk about interest compounding, we're really saying is interest being paid more than once a year. And here it says he can earn 7.5% per year. So we're just going to assume that the compounding rate on this interest is an annual rate. All right. Now, if it's not an annual rate, then we'll need to make an adjustment. This is a really important note that I'm fixing to make. So write this down, add it to your notes, whatever works best for you. But our compounding periods, our payment periods, and our term all have to be in the same units. Okay, so our payments, our interest rate, that's really what I say when I say compounding periods, I mean interest rate. So our payments, our interest rate, and our term all have to be in the same units. And so if we have monthly compounding, then that means that our interest rate is going to be monthly, which means that our term needs to be monthly. And if there's a payment, the payment needs to be stated in terms of a monthly payment. We'll come back and look at an example as we work through these problems that illustrates this point. Here, though, compounding is annually, no adjustment needs to be made. All right, so once I've looked at that, really the question becomes, what am I looking for? What am I trying to solve for? Now, as you get better at this, that'll become pretty apparent. A lot of these problems that we're going to be working early on in class are also pretty straightforward. And so if we have the 5 TVM functions, present value, future value, interest rate, term, and payment, we know we've got to be solving for one of those 5. And so we can look at this and say, well, which one of those 5 is this question asking for? And this particular question is asking for a future value. Okay, now if you didn't know that, then an easy way to figure out what the question is asking for is to input the values for the 4 functions that you do know, and whatever's left over is what needs to be solved for. Okay, So let's go ahead and set this up in Excel. I'm going to read it one more time because it's been just a second. Alex received $30,000 from an inheritance, and he wants to invest it for the next 20 years. If he can earn 7.5% per year, how much will his account be worth at the end of that period? Okay. So here in number one, we have a present value. Our present value is $30,000. Now, I talked a little bit about this in our intro to TVM video. When we're looking at these cash flows, one of the things that we need to determine is, are we looking at a cash inflow or are we looking at a cash outflow? And in this case, we're looking at a cash outflow. Now, that seems a little bit weird because it says that we received an inheritance of $30,000. But if we look back at this problem, the very next thing that it says is Alex wants to invest it for the next 20 years. And so we determine inflows and outflows relative to the client's pocket. Alex received the $30,000, it went into his pocket. Okay, when I say pocket, what I really mean is it went into resources available for consumption. All right. Then immediately after receiving it, he places that money in an investment. So that came out of resources available for consumption and went into investment intended to grow. All right. So in this case, our present value is a $30,000 outflow. We'll note outflows by making them negative. Okay. So we just need to input a negative 30,000. Now we already determined that future value is what we're looking for. We said that our interest rate was 7.5%. Okay, so in Excel, we've got to enter that 7.5% as a percentage, so 0.075. He's going to let that investment ride for 20 years, and there is no payment. We established that earlier as well. Okay, so if we're setting this up, which I encourage you to do it this way, right? I encourage you to type out all the functions and input the numbers associated with that function. Okay, so now we can see, as we previously stated, that this is a future value problem. All right, now that we have it set up in Excel, I'm going to go ahead and work it in Excel, and then I'll work the exact same problem in the calculator. Okay, so our future value, we're just going to hit the equal sign. When we do that in Excel, it does a couple of different things. I'm going to take that out. Let's note this column really quickly, or this box. Right now, when I'm clicked on this cell in Excel, it's telling me in this box that you are on B5. Okay. This f of x, this is my formula function, right? And it doesn't really have anything going on in it right now while I'm just clicked on that cell. Okay. As soon as I hit equals, you'll notice that that named cell box turns into a formula function box, and you'll notice that our f of x says equal. It's like, all right, what formula do you want to input so that I can perform the calculation that you're looking for? Okay, so I'm going to use this drop-down box. I'm looking for future value. Okay, so I don't see that in my list of available formulas right here. So I'm just going to click on more functions. Okay, and then I'm going to search FV. I want future value. Okay, it pulled up FV for me right here, and I'm going to insert this function. Okay, when I do that this way, it pulls up a nice little box that makes it nice and easy for me to perform this calculation. All right, so the first thing it asks me for is my rate. So my rate right here is my IY, and so it's going to say, all right, I'm referencing cell B6 for your rate. Your number of periods is your N, that's 20. Your payment, we said, is 0. Your present value is the negative 30,000. And then this is asking for a type. When this is asking for a type, it's asking for, is this an ordinary annuity or an annuity due? Okay. Now, if we input 0 right here, it's saying that that is an annuity due, a payment that happens at the beginning of the period. If we insert a 1, that's saying it is an ordinary annuity, a payment that takes place at the end of the period. Well, we don't have a payment in this calculation, right? It says right here that our payment is 0. And so we can either leave this blank or we can input a number. I'm just going to leave it blank since we don't have it, because it won't impact the calculation, right? For ordinary annuity or annuity due to matter, there has to be a payment, and we don't have one here. Okay, so once I'm done with that, I can just hit done. And it tells me that my future value after 20 years, this $30,000 investment, if it earns 7.5% per year, is going to be worth $127,000, roughly $127,000. All right, now we get a very specific answer here. The reason I say roughly $127,000 when I look at this is because I want to point out the fact that we're making assumptions here, right? Our main assumption in this problem is that Alex is going to earn 7.5% per year for the next 20 years. That's not how investments work more often than not, right? He might earn an average of 7.5%, but more likely than not, that's going to be variable year to year. The chances of us getting this rate of return correct are not good, right? We can be close. It's an estimate to the best of our knowledge. And so if our input is an estimate, our answer is also an estimate. So even though we get a very specific dollar amount here, which helps validate that you did the problem correctly, the answer in reality of speaking to a client is about $127,000, right? Or about $125,000, because we are, again, just making an estimate. Okay, let's do the exact same problem in our calculator. Now, our calculator works a little bit differently, okay? The reason I like to do this in both formats is because I think Excel is really, really friendly to practice, right? If you were performing some TVM calculations on some different financial statement items to build financial statements as an example, then you'd probably do that in Excel so that your calculation automatically transferred over to the right account in the financial statement, and it just links up really nicely. We're going to do that this semester, and so I want to make sure that we're equipped from the very beginning. When you sit for the CFP exam, you're going to have to do these things in a calculator, right? The CFP exam in its current format does not allow for computers in the testing site. You can have a non-programmable financial calculator, which is what this is. And so you need to be able to perform these functions inside your financial calculator. All right, so again, here are our 5 functions. In some cases, when we're working in the calculator, order matters. In some cases, it doesn't. So an example of when order does not matter is I can input the numbers to these functions in any order that I want to. In other words, I can input the present value first and the future value last, or I can input my term first and my interest rate last. It doesn't matter what order we input the numbers for the functions. What does matter is the order in which we push the buttons, okay? So I'll illustrate that as we work this problem. All right, so we have all of our stuff over here. Let's see if we can match our future value answer of $127,435. Okay, so it said we had a $30,000 outflow as our present value, okay? So when we're entering these, we're going to enter number first, and then the function that the number belongs to. Okay, so I entered $30,000, made it negative right here, and then assign that to the present value. Okay, once I've done that, I can just move on down the line. I can say 0 is my payment. I can say that 7.5 is my IY. All right, now notice that's different in the calculator than what we did in Excel. In Excel, we entered a percentage, right? 0.075 for 7.5%. In the calculator, we entered a whole number, 7.5, to represent IY. Don't get these confused. That's a difference between the calculator and Excel. Calculator takes whole numbers, Excel takes percentages. Okay, 20 is our in. All right, now all we're doing is looking for our future value. So when I want to compute a TVM function, I'm going to come up here and hit this compute button. And then I'm going to hit the function that I'm looking for. Okay, I'm looking for the future value. And just like we got in Excel, $127,435.53. Okay, so again, the order number first, then the function that the number applies to. Once we've entered all of our information, we want to hit compute and then the function that we're looking for. If you get out of order on those things, you will have a headache on your hands, right? The calculator is not going to perform the functions the way that you want it to. Okay, now one little side note that I want to make is that compute is a very distinct function in this financial calculator. It is not the same as enter. It is not the same as equals. Okay, these three buttons all perform very distinct functions, and so you can't use them interchangeably. All right, let's do some more practice. Practice makes perfect, and I think that you'll catch on to this pretty dang quick. All right, so let's look at number 2 now. It says Jane needs a total of $75,000 in 10 years to pay for a 4-year college education for her granddaughter. If she can earn 6.5% per year after tax on her growth fund, how much does Jane need to invest today? All right. So again, let's go back to it. Does this thing have a payment? All right. I don't see anything that's happening on a recurring basis for a set period of time. And so my answer here is there is no payment. Payment equals 0. Okay. The next thing we need to ask ourselves is, does the interest rate compound more frequently than monthly? It says 6.5% per year. I don't have anything to lead me to believe that it's more frequently than that. So we can say that's going to be an annual compounding rate. Okay, all good. And then the last thing that I need to ask myself is, what are we looking for? Okay, well, the last thing in this question says, how much does Jane need to invest today? All right, so that's a pretty good keyword for the fact that we're looking for a present value. All right, so let's jump in and let's enter this information and work this calculation. So we just determined that present value is what we're looking for. It says that Jane needs $75,000 in 10 years. So we're going to enter that as our future value. Now, this is an inflow to Jane. All right. In 10 years, Jane's going to be receiving $75,000 from her investment that she can use to pay for her granddaughter's education. Okay, so that is an inflow. Our interest rate here is 6.5%. Our term is 10 years. And again, our payment is 0. So we want to know, how much do we need to invest today if we earn 6.5% per year for 10 years to end up with $75,000 at the end of the 10-year period? Okay, so I'm going to come back to this. I'm going to hit equals. I'm going to go to my drop down, and I'm going to choose, in this case, present value. It's available as a function. Okay, so again, it asks for my rate. I'm going to choose 6.5%. My number of periods is 10. Our payment is 0. Our future value is 75,000. And again, I can leave this blank because there's 0 payment. Now, one thing I do want to point out to you real quick is that Excel is color coding this, right? So it's like, hey, listen, I'm using B13 as your rate. And so B13 is blue here, and the corresponding cell is also highlighted blue. Same thing, my number of periods is red, my number of periods is red. And so that just helps you connect if you get confused on what you're assigning to each function. All right, so I can go ahead and hit done here, and I get $39,954. Now, a common thing to occur right here is for someone to freak out, right? Like, oh my gosh, I got a red negative number as my present value. There's no way the initial investment can be negative if we're trying to get to a positive $75,000. Remember what these TVM functions are telling us, right? It's not saying that this is a negative number. It's saying that this is an outflow, okay? So we got to have an outflow from the client's pocket into the investment account of $39,900 today, so that we can have $75,000 10 years from now, given the assumptions below. Okay, so just make sure you understand what that means. All right, let's move on and answer the same question in the calculator. So we're going to go $75,000 is our future value. 6.5 is our IY, 10 is our N, 0 is our payment, and then we can hit compute present value. And we get the exact same answer, okay? Again, calculator just telling us that that number is an outflow. All right, let's keep on going. I'm going to say it just so that it gets reiterated in your brain. When we're entering into the calculator, number first, function that the number applies to. Once you have everything entered, hit compute and whatever it is you're looking for. All right, now, one thing I didn't do between problem 1 and problem 2 is clear my TVM register. All right, so there's two ways that we can work these TVM problems. The way that I just did it is I overwrote the previous entries that I had from problem 1. So I entered a number for every single function. And when I enter a number for the function, it overwrites the previous entry for that function. All right. This is what I would call the experienced way. If you forget to overwrite something, the calculator is going to store the previous entry, and whatever it has in there from the previous problem, it's going to apply to the new calculation. So if you want to be more safe, when you're done, you can hit the second key, and then you can hit clear at the bottom, right? It says clear work. And so that'll clear out your entire TVM register so that basically all of your TVM functions equal 0. And you can start fresh with your next problem. All right, let's look at number 3. Roland has an $8,000 balance on his credit card. If he stops using the card and starts paying $500 at the end of each month and the card has an 18% interest rate, how long will it take him to pay off the balance? All right, so first question is, do we have a payment? And in this problem, we do, right? We're making $500 payments at the end of each month. And so that tells us that we have something that's recurring for a set period of time. Okay, so if the answer to do we have a payment is yes, the next question we need to ask ourselves is when does that payment take place? At the beginning or the end of the period? Okay, in this particular example, the payment takes place at the end of each month. And so when we have a payment that takes place at the end, that's an ordinary annuity. All right, so we do have an ordinary annuity in number 3. The second question we have to ask ourselves is, does the payment take place more frequently than annually, right? And the answer is yes. Okay, so this is very similar to the question is, does my interest rate compound more frequently than annually? So it says that our payment takes place each month. And so what this tells me is that I'm going to have to do some conversion to make sure that my payment, my term, and my interest rate are all stated in monthly units. Okay. And so then the last question is, what is this looking for? And so the question says, how long will it take him to pay off the balance? And so we are looking for a term for this problem. All right. So let's go set this baby up and let's answer this question. Okay, so Roland has a current credit card balance of $8,000. Okay, that's the present value. Anytime we're dealing with loans, the loan amount or the loan balance is the present value. Okay, when we're dealing with loans, the future value is going to be 0, right? We're going to pay it off in full. Okay, our interest rate, it says, is 18. Now on this, I'm going to hit equals because I'm going to input a calculation into this interest rate cell. Right? It's 18%, but because that's an annual rate, I need to convert it to monthly rate so that it matches my monthly payment cycle, right? So I just need to divide this by 12 to get to a monthly rate, right? So anytime we're converting our interest rate to something other than annual, then we need to divide that interest rate. If we have a quarterly interest rate, we need to divide it by 4. If we have a monthly interest rate, we divide it by 12. If we have a semi-annual interest rate, we divide it by 2. Weekly by 52. You guys get the point. All right, so here we need to get it to monthly. We'll divide it by 12. Okay, Up next, it asks for our in, that's what we're looking for. And our payment is $500. Now this payment is an outflow, so we'll make that a negative $500, and we're ready to solve this problem. Okay. So let's say equals here. And let's see if it has number of periods. It does not. So let's search for NPER, right? We've seen in our other calculations that it defines our N as NPER, number of periods. And so let's select that. And let's solve for our problem. All right, so it's asking for our rate. We have that as our rate. Our payment is there, present value here, future value. Now, type is important here, right? We said that this payment was taking place at the end of the month. And so we need to insert a 1 right there to make it an ordinary annuity and hit enter. Okay, so the N that we calculate is 18.12. All right. Now, what this represents is months. My payment is monthly. I converted my interest rate to a monthly interest rate. And so when I do that, my number of periods will also be in months. And the reason for that being, to sound like a very broken record, is that our interest rate, our term, and our payment all have to be in the same units. Okay, so now we have all monthly units for those three functions. Okay, if I wanted to know how long that took in years, then I could divide it by 12, right? It would give me a 1.5 years to pay off. But since our payment is monthly, this is probably most appropriately stated as months, right? If we went back to the client, we could say, hey, listen, you're going to have to make 18 $500 payments to get this thing paid off. All right. Now let's do that in the calculator. So we have $8,000 is our present value. 0 is our future value. Now, again, for our interest rate, we use whole numbers. So I'm just going to say 18 divided by 12. Now, it's important that you hit equals here. So you hit equals and then assign that to IY. Okay, if you don't hit equals, it's going to put the last number that you entered in as the interest rate. Okay, and then we have 500 negative as our payment. And we can compute for our N. All right, so I got something a little bit different there. And it probably has a lot to do with some rounding. And so sometimes we get that with Excel versus the calculator, where we have just a little bit of a rounding difference in our calculation. I'm gonna clear this out real quick though, and I do want to see. All right, so let me backtrack just a little bit on what I just said. I apologize. I got confused. The number 0 is ordinary annuity. The number 1 is annuity due. So my calculator and Excel actually do match. Both of these are set to end now. And so I do get the same answer. So just for clarification, a 0 is for payments that take place at the end of the period. A 1 is for payments that take place at the beginning of the period. I apologize for that confusion. All right, so a question comes in then, how do we know that the calculator is set to end, right? Is set for the payment to take place at the end of the period? Well, the first thing we can do is just look in the top right-hand corner of our display screen. If it's blank, then that tells us that our calculator is set to end. All right. If there's a BGN in the top right-hand corner, that tells us that our calculator is set up to estimate the calculation based on a payment that takes place at the beginning of a period. All right, so I know that I'm set to payments at the end of the period because this is blank. Now, if I needed to change it, then I could hit the second key. After I hit second, hit payment, and that's going to tell me what I'm set to. All right, it tells me I'm set to end. If I wanted to change it to beginning, now I can hit second and then enter. Okay, and if I want to change it back, second, enter, second, enter, second, enter, right? That changes it. Okay, so I'll show you again. Second, payment to see what I'm set to, and then second, enter to change it. Okay. All right. So again, we get 18.43 months. Okay. let's move on and let's take a look at question number 4. Just for what it's worth, we're moving pretty slow today through these just to make sure that our thought process and our setup is correct. As we continue with these practice problems in the lectures that I will post after today's lecture, we will pick up the pace for sure. I don't want to make this any more painful than it needs to be. All right. So number 4 says, what is the present value of an 8% 10-year, $10,000 ordinary annuity paid annually? All right, so if I ever see a $10,000 followed by ordinary annuity, this is telling me that this is a $10,000 payment that takes place at the end of the period. Okay, so do I have a payment? Yes. Does that payment take place at the beginning or end? Well, it tells me it's an ordinary annuity, so I know that it takes place at the end. Does it take place more frequently than annually? No, it tells me that the payment takes place annually. All right. So the last thing I need to know is, what am I looking for? This problem is pretty direct. It asks, what is the present value? So before we go into working this, let me just talk about what this is asking for. All right. A pretty common longevity insurance product is an annuity. Okay. And so when we say a longevity insurance product, an annuity is set up to basically guarantee income for a set period of time. Okay. And so some annuities will pay out until death. Some annuities will pay out for a 10-year period or a 20-year period, but no matter what, the timeline on the annuity payout is established on the front side of the contract. Okay. And so basically what this question is asking for is, how much of a lump sum would I need, or would the client need, to produce $10,000 annually at the end of each year for the next 10 years if the original amount could earn 8% per year? Okay. So another way of looking at that is, how much would longevity insurance cost up front if these factors were true? Okay. And so as we work this problem, I'll talk about the answer in the context of the way that I just set that up. All right. So let's come in here and let's work number 4. I'm going to start with our payment. Okay. In this case, the client is receiving a payment. They're receiving $10,000 at the end of each year. So that is a positive number. They're going to be receiving that for 10 years. The interest rate is 8%. So we need to enter that as 0.08. Our future value is going to be 0. All right. Basically what we're saying is, whatever money goes in up front will be distributed over the course of the 10-year period. There will be nothing left at the end of 10 years. That's why our future value is 0. Okay, so now what we're looking for is the present value. Okay, so we can just hit equals. We can come up here, we can choose present value from our functions, and we can start assigning our functions. Again, this is going to take place at the end of the period, so I'm going to input a 0 right there and hit enter. Okay, so let's talk about this answer. I think this will make sense now that we have it calculated. So what this is saying is, let's think about a client in retirement. If the client needed $10,000 per year in retirement over a 10-year period, and they thought they could earn 8% on their invested money, then they would need to have $67,100 invested to accomplish this goal. Okay. The other way of looking at this is, if the client wanted to purchase longevity insurance, and the longevity insurance contract said, hey, listen, we're going to pay 8% on the upfront money. And if you need $10,000 over a 10-year period from this longevity insurance, then the cost of the insurance is going to be $67,100. Okay. So really what we're looking at under either one of those thought processes is, how much money do we need in a lump sum to convert to our desired stream of payments over time. So if I need $10,000 for 10 years and I can earn 8%, then I need $67,000 on the front side. Okay. Let's look at this in our calculator as well. Okay, so we know that we need to be set to end. My calculator's blank up top, which means that we are set to end. And so now I can just enter these functions. So $10,000 is my payment. 0 is my future value. 8 is my IY. 10 is my term. And I can compute the present value. Okay, 67,181 cents. So we got good answers to match. Again, this is negative because this is going to be an outflow on the front side. All right. So now let's go and let's take a look at number 5. Number 5 says, repeat the question above for an annuity due. All right, no problem. Here, I'm just going to copy this, right? I'm just going to say copy. If you're using a Mac, that is Command C. If you're using a Windows product, that is Control C. And then I'm going to come down here and I'm going to paste it. So if you're using a Mac, Command V, or if you're using a PC, then Control V will copy that stuff. Okay, so I just selected it by clicking and dragging my mouse, and then I just copied it and then inserted it into the cell that I wanted to work with. All right, so let's open up our calculation. Okay, so this is a different way of looking at this. Again, Excel is going to use the color coding system. They're going to say the blue number corresponds with the blue cell. That is your interest rate. Okay. Now, if I move over with my cursor, it'll tell me, like, you're looking at your rate right now. Rate is bold and underlined. That is the number. That's the cell that you've referenced for your rate. Okay, that's your number of periods. That's your payment. That's your future value, and that's your type. Okay, so all we need to do here is we need to just change our type to where the $10,000 payment takes place at the beginning of the period. Okay, once we do that, we can just hit enter. And it gives us our new answer, $72,468. So why do we need more money up front if the distributions are going to take place at the beginning of the year? Well, the answer is pretty simple, right? I'm losing a compounding period, okay? If we drew this out on a timeline, right, and we said, hey, listen, this is now, this is 1 year from now, 2 years from now, 3 years from now, okay? Under the situation to where we have an annuity due, where the payment takes place at the beginning of the period, this first distribution is going to happen immediately, okay? And so what that does is it reduces the balance up front, so we have less dollars earning interest, which means that we need more dollars to accomplish the objective, okay? So this is for the annuity due. If we're looking at it from the perspective of the ordinary annuity, the first $10,000 distribution does not take place until here. All right, so our money stays in the account for longer. Our balance is bigger for longer, which means that we earn more interest, which means that we need less dollars to accomplish the same objective. Okay, and so that's why the annuity due requires more money to produce the same benefits in comparison to an ordinary annuity. The annuity due loses a compounding period on the upfront balance. Okay, hopefully that makes sense. Let's just clear that out of there so we're not wondering what that is later. And then let's look at number 6. Number 6 says, what is the maximum you would pay for the annuity or for the longevity insurance in question 4? All right, now I want to make one qualifying statement before we answer this question. I'm going to change this to say, what is the maximum you would pay if timing didn't matter right? If it didn't matter if your client received the payment at the beginning of the period or at the end of the period. Sometimes it does matter, okay? But in this case, let's say that timing does not matter. And so what's the maximum amount we would pay for the annuity in question for, and why? Well, if timing doesn't matter, and all I need is $10,000 for 10 years, and I think I can earn 8% on my upfront money, then the most I would be willing to pay for these benefits that are identical is the answer that we calculated in number 4, right? If I can get a stream of payments of $10,000 for 10 years and timing doesn't matter, then I want to pay the cheapest cost for that stream of payments. Okay, and the cheapest cost based on our calculation for that stream of payments is $67,100.81. Okay. All right, we're going to stop there for today. I'll come back with 2 additional lectures over these in-class practice problems. I'll work the next 6 problems in the following lecture, and then in the last lecture, I'll finish up the remaining problems for the exercise. If you have any questions, please let me know. I hope this is getting you off to a great start, and I'll be back with more content soon.